population proportion. So here P denotes the population proportion, which is equal to capital X by N. N is the population size and X is the number of units which is having a specific characteristics. Okay, so we will be using this testing of proportion when our population is characterized on the basis of any one of the properties. Okay, for example, in a human population there will be some people who are cinema lovers, that is who will be going for cinema, and the person who will not be going for cinema. So there is a characterization. And if we consider a population, there will be tea drinkers and non-tea drinkers. So these are the examples. So if you are given a population like this, we have to uh, check whether the population proportion is so and so. Okay, in that case we will be using this test. Or otherwise we can say that if we want to check whether a die or a coin is unbiased, so we don't know how the number of actual successes to the total number of trials, so we will be conducting this experiment, or we don't know whether this die is unbiased or not, so we will be conducting an experiment in a number of time, and out of these number of times we will be getting some number of successes. So that's again a case of testing of population proportion. So P is population proportion, which is equal to capital X by N, and P naught is the assumed value of population proportion in the problem. So this will be given in the problem. And P dash is the sample proportion, so which will be small x by n, where n is our sample size and x is the number of units having this specific characteristics in the sample. Okay, so the number of units is having a specific characteristics in the sample is x. Okay, now we are going to test whether our population proportion is equal to some value. So this is proportion. So this proportion is defined as capital X by N. So N is the total population size, and out of that population we are having a group having specific characteristics. So this P naught will not be greater than 1. This will be always less than 1 and greater than 0. So this value lies between 0 and 1. When you are given a problem to test the population proportion, remember that the value of P naught will be lying between 0 and 1. So this is our null hypothesis, and our alternative hypothesis is H1P not equal to P naught, and or we will be using the alternative H1P less than P naught or H1P greater than P naught. And our test statistic will be Z is equal to P dash minus P naught divided by root of P naught Q naught by N, where Q naught is 1 minus P naught. Okay, Q naught is 1 minus P naught. And after finding a test statistic, we will be looking for our critical region. So if H1P not equal to P naught is our alternative hypothesis, our critical region will be modulus Z greater than or equal to Z alpha by 2. And if H1P less than P naught is our alternative hypothesis, then Z less than minus Z alpha will be our critical region. And H1P greater than P naught is our alternative hypothesis, then Z greater than Z alpha will be our critical region. So after finding the value of Z, we have to find the value of Z alpha or Z alpha by 2 from the tables, or you can use the value of Z alpha or Z alpha by 2 corresponding to 1%, 5% or 2% level of significance, which is given in the previous videos. Okay, so the only chance of coming for the examination, the level of significance coming for the examination is 1%, 2% or 5%. So if you by heart that value, you can use that value for Z alpha and Z alpha by 2. And after comparing Z and Z alpha by 2, if the value of Z lies in the critical region, you can reject the null hypothesis, otherwise you can accept the null hypothesis. This is the testing procedure for testing of proportion of a population. Okay, thank you.